The last thing I'm going to show here is same idea. We're going to test 3 different ways of doing this processing, except now we're going to use IntStream rather than stream. So just a quick refresher on IntStream versus stream. Stream is an interface that's parameterized by type T. Type T is intended to be a reference type. Reference type would be things like string or integer or capital L long or whatever. Whereas IntStream, as the name suggests, is a stream of primitive ints. So it's not parameterized by anything. And it's often faster because you don't have the overhead of having to box the values. Now, as always, when you start doing things for real life, sometimes other factors dominate, and in fact they do here, but it's just kind of fun to see how it works for the IntStream variant. So we'll start by taking a look at the flatMap test, which looks very similar at the outer level, but the implementation is slightly different. And the reason the implementation is slightly different than the stream version of this is because we don't have a box between ranged, closed, and dot parallel. So instead, we have an IntStream, and we do this stuff, and it returns an IntStream. So we're just dealing with a stream of ints. There's no need to box anything up. So that should be a little bit faster. Likewise, for InnerStream over here, you can see the same thing. Basically looks almost identical to what we had in the stream version, except we don't have to box anything. So we're going to end up returning an IntStream rather than a stream of integers, which sounds kind of funny because it sounds like it's the same thing, but it's implemented differently and more efficiently for these primitive types. So that's flatMap. Not a whole lot of difference in flatMap. Let's take a look at testMap. That one actually is more different. So again, we are going to generate the outer stream with an IntStream. And now we're going to use map. And what map's going to do is it's going to call this InnerStream method, which returns an IntStream. And what we're going to do is, because it's an IntStream, we just put a sum here, and there's no need to have a separate reduce phase. This sum is basically acting like reduce. So unlike the previous implementation we looked at, if you recall, for the stream test where we did map, which is the one up here, this one generated the outer stream, used map, and then we had to do reduce followed by or else. Because we're working with an IntStream, we don't have to do that extra phase. All we have to do is basically just sum the results. So that tends to run pretty nicely, but other than that, it looks pretty much the same. And then the third and final implementation here, again, looks very similar at first glance. It generates the outer stream, uses mapMulti followed by allMatch. And the little tiny differences are here in InnerStream EX, where once again, we don't have to box anything. And so we don't, by not boxing anything, then that gives us the benefit of having things, at least in theory, running faster. Other than that, though, it's really pretty much the same code. So you can get very similar behavior, or sorry, very similar implementations with IntStream versus stream of X or stream of T, which is stream of integer. So just to remind us what the results were for doing this for a large N, not a small n, let me show you. I had taken a screenshot of what this was earlier. So here was the screenshot from earlier where I had run this with 100,000 outer stream elements. And you can see, interestingly enough, that the version that was the reference type actually performed the best. It performed better than the IntStream version. So when N gets very large, the parallel processing is what's dominating. And I'm honestly not sure why this is performing better than the IntStream one, because you'd think they would be you'd think that not having to box stuff would be a win. But these are the results. I suspect there's probably other things going on here. If I run these tests a couple times, you'll sometimes see slight perturbations in who wins. But you always find that test flatMap loses because it's running sequentially, thereby demonstrating the downside of putting yourself in the Procrustean bed of limitations with flatMap. So the good news is, at this point, you now have knowledge of why flatMap can be deficient. But if you need the kinds of things that flatMap is doing, which is basically flattening out nesting of streams, which we don't want, then you now know 2 ways to solve that, using either map and reduce with stream concat, or by using multi-map. And the multi-map approach works quite well. And that was neat, because I didn't know much about multi-map till I ran these tests and then realized that it was working quite well and was straightforward to program. I think the interesting thing is the flatMap version is arguably the simplest one to look at, but it doesn't perform very well. The map reduce approach is a pretty straightforward cut and paste replacement of flatMap. You just have to get rid of flatMap and use map, followed by reduce, and with concat. Pretty straightforward to do, runs better than flatMap. And then the mapMulti approach requires the most different programming. It's not that much harder, but it's a little different, but it performs very well. So as usual, you have to pick and choose what you want your trade-offs to be.